All right, welcome class, and once again we're going to talk about acids and bases, and we're going to come close to wrapping up the chapter. We won't be completely done with everything that we're going to talk about in this video. We will do some other stuff in class, but this is going to be our last video on acids and bases. And the one major thing that we have not talked about in acids and bases is what do acids and bases do to each other? And we call this a neutralization reaction. Obviously, if you're looking at the pH scale, you have acids on one side and bases on the other, and in between you have neutrality. Okay, 7 on the pH scale being neutral. We talked about comparing the hydronium ions and the hydroxide ions, and we said that as one moves up, okay, so you increase the concentration of one, you decrease the concentration of the other by the same amount, so they move in relationship with each other, and that's how we get the pH scale. So we're going to take a look at, and we use this often in real life, neutralizing acids and bases. Maybe a practical way that you can think of it is you may have some medicine in your cabinet at home, and sometimes maybe you get an upset stomach, or sometimes what we might refer to as heartburn, which actually has nothing to do with your heart. Generally speaking, you may have some excess acid, and maybe because you ate some acidic food, or it could be a number of reasons for it, and you feel this pain kind of in your chest. We call it heartburn, and you can take some medicine to alleviate that. Okay, the medicine that you usually take is what we call an antacid. And all really an antacid is generally speaking, if you look on there, it could be one of a number of ingredients, but often it will be some kind of base. Okay, and so what are you doing? You're neutralizing some of the acid that's in your stomach. Obviously, you're never going to neutralize all of the acid in the stomach, and you don't want to, because you need some of the acid in your stomach to digest your food. But any of that excess acid, they will use what we call an antacid, which is basically a base. So that's kind of a real simple, practical thing. Sometimes farmers will use it. They'll test their soil to find the pH level of their soil. And if it's one side or the other on the pH scale, then they're going to adjust it so that it will be the level that they want. Okay, so they do this in soil testing, sometimes in water testing. They do that as well in water plants, to be careful to make sure that the water is not acidic or basic. So let's take a look and define what is a neutralization reaction. It's basically a reaction in which an acid and a base combine to form water and a salt. And knowing what it forms, that's key, and we're going to emphasize that again in a minute. And the salt there that we're talking about, let me just go ahead and mention this. It is not necessarily table salt, even though in the example we're going to use, that's kind of what we'll show here. So what does this look like? Okay, here's an example of a neutralization reaction. And I would want you to be able to kind of write a neutralization reaction, or tell me what a neutralization reaction would look like in general. And so here's just one example. I picked one acid, and in this case it happens to be hydrochloric acid. If we want to highlight that here, here is our hydrochloric acid, and then this is, which is our acid, and we know that because it's got a proton here, okay, the hydrogen. Sodium hydroxide is our base. We know it's our base because it has a hydroxide. And so basically what you've got going on here, no pun intended there, is this is a double replacement reaction. If you remember earlier in the year, we talked about types of reactions, one of them being a double replacement reaction. And so you're going to have sodium here swap with hydrogen, and hydrogen is going to come over here where sodium is. And so if you look at your product side, what do you end up with? You have sodium combined with chlorine to form sodium chloride, or what we know as table salt. And then you have this hydrogen over here combined with the hydroxide to form H2O, or water. And so those are your two products as a result of this reaction. And that's true of any reaction that you have a neutralization reaction. You're always going to produce water and a salt. You'll notice I put a salt here. Salts can take the form of a number of different things. It could be potassium chloride. It could be sodium sulfate. You know, there's a number of different, basically any metal with any ionic non-metal, and they can be polyatomic ions as well. Those are what we call salts in general. And salts can actually be semi-acidic. You can have acidic salts and neutral salts. You can have basic salts. We're not going to spend a lot of time discussing those right now. But the main thing that I want you guys to understand is that when you have a neutralization reaction, the two things that are produced are water and some sort of salt. Okay, so that's the result of a neutralization reaction. And the goal is basically to get your pH, generally speaking, around 7. Now, part of the way we do that is through what we call acid and base titrations. And titrations is basically you have a certain amount of, let's say, an acid, and you want to neutralize it. So obviously, what are you going to neutralize it with? A base. And so let's say you have a certain base. What we want to know now is basically, well, here's my acid and here's my concentration of that acid. You know, so let's say it's a 3 molar solution of hydrochloric acid. All right, and I want to neutralize it, so I want to get it to a pH of 7, and I have, let's say, 30 milliliters of that acid. Well, on the other hand, I have a base, and let's say I know the concentration of that base. So let's say it's a 5 molar solution of that base. Well, obviously your base is a little bit stronger than your acid. How much of that base are you going to need in order to neutralize the acid? How many milliliters are you going to need? Because it's not necessarily going to be the same amount. It's not just, well, I have 50 milliliters of an acid and I'm going to put 50 milliliters of a base together, because they're not necessarily the same strengths. So that's where we end up doing a little bit of math, and this is where what we call titration comes in. And we'll actually play around a little bit with some titration later on, I think in a future lab. But here's the formula. And basically you have M, if you remember, capital M, there is molarity, and you have molarity on both sides. And if you'll notice, you have molarity of the acid, that's what the lowercase a here is, times the volume of the acid. And that's usually given in milliliters, and that equals the molarity of the base times the volume of the base. Okay, so this is the titration formula. And so usually you'll be given 3 of these, and you just need to solve for the other one. So it's usually a fairly simple formula. So I may know the molarity of the acid and the volume of the acid, and then maybe I know how much of a base I have, but I don't know, what the molarity of the base needs to be in order to neutralize. So I need to figure that out. Or maybe I know the molarity of the acid and the volume of the acid, and I know the molarity of my base. So now what I need to figure out is how much of that base do I need to add in order to neutralize it. Okay, so an example formula would be something like this right here. And I'm provided with some information. In this case, I'm told I have 108 milliliters. And so if I look at that, that would be my, this right here would be my volume, because it's milliliters. And that's going to go, that's of my base, because it goes with sodium hydroxide here. And so if I'm looking at that, I'm going to put 108 over here. And that's going to be times my molarity of my base, okay, which in this case is 0.005. Okay, and that whole thing equals, and then let's see, what information do I have over here. It tells me I have nitric acid. It does not tell me my molarity, so that's going to be my X, okay, I don't know what that is, times 36 milliliters. So 36 is going to be what I know over here. And then I'm going to go ahead and do all my math here, and I'll leave that to you guys to kind of calculate, and then I can solve and find what my molarity is. So that's really how you would set it up. It's pretty simple, pretty basic, and what that allows us to do is be able to figure out, well, how much of a base will I need to neutralize this acid, or how much of this acid will I need to neutralize this base, or what strength will I need of this particular acid to neutralize this base, or concentration. And so I can kind of move between those and figure out what it takes to neutralize something. This comes in handy, for example, in some of the labs we do. And when you guys are done and you've been using an acid, and at the end of the day I have to neutralize something, if I know what the strength of the acid that we've been using, and now I need to neutralize it before I flush it down the drain, then that lets me know, okay, what kind of base do I need to make, and how strong does it need to be to add to my my acid, so I can neutralize it and then flush it down the drain is basically harmless. There, so that's kind of some practical examples there, and we call that titration. And that brings us basically to an end. We'll do some practice with this in class, but other than that, we are basically done.